right. Hello, everybody. Glad that you are joining our session here on What's New in Compose Multiplatform, subtitled Building Shared UI for iOS and Beyond. My name is Sebastian. I'm one of the developer advocates at JetBrains, specializing in Compose Multiplatform.
And my name is Márton, and I do the exact same thing.
So you'll be in great hands for the story that we have laid out for you today. There's a couple of things that we want to go through. We want to talk a little bit about how Compose Multiplatform is capturing the world where it is today. I want to talk a little bit about what we're doing to make onboarding and tooling support better. Then, of course, since we're talking multi-platform, there are a bunch of things that are just useful across all the different shared platforms. But of course, we're also investing in platform-specific updates as well that we want to show off to you. So let's get started.
OK, let's start at the start with what Compose Multiplatform is. So it's a UI framework that allows you to build shared UI in Kotlin for all of our supported platforms, which are Android, iOS, desktop, and the web. It's already fully stable and production ready for mobile, desktop, and it's in beta for the web, which is a recent improvement. And so we're going to be looking at, for example, what's new in that web beta later on here. Now, one of the really great things about Kotlin Multiplatform in general is that it allows you to pick which parts of your apps you want to share. You can start from 1% of shared code and go to 100% shared code if you want. You can have one small bit of logic. You can have all of your business logic. You can also add UI sharing to the picture with Compose Multiplatform. So it's really up to you to decide how you want to introduce it into your code base. And even within that UI sharing use case, you can still have both native UI and shared UI in your apps, if you'd like to.
And it's exactly this kind of flexibility, really, that helps companies also adopt Compose Multiplatform quite easily. Márton, when you came here today, you booked your flights, I think, using Perk, right?
I did.
And, well, so you did it in an application that partially adopted Compose Multiplatform in a brownfield application. So they had existing apps, and they, component-wise, adapted Compose Multiplatform here. It's a particularly interesting story, but I don't want to take away all of that. Instead, you can read their own case study. Don't do it right now, please. Let's do it a little bit later. But there's a wonderful blog post that outlines all the benefits that they get out of this pick and choose approach to doing multi-platform development with Compose. And of course, there's a couple of other ones. If you want to hear an extended case study here at KotlinConf, check out Sergio's talk about Sony's KMP story. No spoilers. He can tell that story best. And there's a couple of apps which maybe you also saw this morning, and you might not have used them yourself directly, but why we really want to point these out specifically is to show off how extremely well Compose Multiplatform scales. There's Alipay here, there's Kuaishou, and there's Tencent Video. And just to point out some of these numbers at what size these applications are operating, we have Kuaishou at 250 million daily active users that are using Compose Multiplatform parts of their application, and 340 million monthly active users for Tencent Video, where again, most of the key flows in the application are built using Compose Multiplatform on iOS and on Android, which is something that we're really, really delighted about, of course. And like you saw this morning, it's also really lovely to see Compose Multiplatform thrive not just on mobile, but also on desktop, with Google adopting it, for example, in their Gemini agent UI that's built into Android Studio. So whenever you're using that, you're also using Compose. So
let's get started with demos. We're going to have a bunch of these during the talk. And for a start here, what I would like to show you is what the getting started experience is with KMP and therefore with Compose Multiplatform at the moment. So, of course, you can generate new projects right there in the IDE. You can create a new Kotlin Multiplatform project. You can pick the platforms, make sure that you choose Share UI if you want to use Compose Multiplatform across all of them. And you can land in a project like this. So what you'll see when you do this is that this project already uses our new default project structure, where we have a share module, which is a KMP library for all of these platforms. And then each of the different platforms that we target, Android, desktop, iOS, and web here. All of them have their own application modules that each wrap that shared library into a runnable application for the given platform. So for example, if we take a look at the Android app real quick, then every line of build configuration in there is going to be related to packaging the Android app. So it's easy to navigate the project because all of these things are neatly separated. And similarly, if we look at its sources, everything there would have to do with launching and packaging the Android application. One of the things that you'll find if you create a new project like this is that if we hop over into the main function, and we're going to run a Gradle sync because I closed my machine since opening this project. So now we're going to attempt to recover it from that state. We also have several projects open at the same time, which of course can make things a little funny.
Just give that a second here. What were you going to be talking about?
So what we should see here is that Compose hot reload, and we have successfully synced. Compose hot reload is part of the default run experience for desktop projects, which makes it easy to create code changes and then see those reflected immediately in a live running desktop JVM application. And while I could show you hot reload on a Hello World wizard project like this, we can also just hop over to a real project, such as the Kotlin conf app, and run that using hot reload for more of a real example. As we open the Kotlin conf app, did you know that there's a Compose Multiplatform talk on in the keynote room?
I got to get there.
Huh. But we're going to go to another screen for hot reload. Let's take a look at, for example, the golden Cody screen here. And if I resize this a bit, we might think that that golden Cody banner, while it's beautiful, might be a bit too large in certain configurations. So we could find where that banner is. And we can edit into the code. For example, we can constrain the width to, I don't know, let's try 300 dps. And you'll see that hot reload kicks in. We start recompiling. And as soon as that finishes, it will inject those changes into our already running application. And we should see those reflected live. Like that. So now we have a constrained size for that golden Cody banner. And of course, it's easy to start iterating from here and find the exact values and the exact size that we might want to see there. As I do these reloads, if you take a look at the code, you can see that a certain scope of the code is flashing, which is actually indicating with IDE tooling which part of the code was reloaded using Compose hot reload. This is something that you can customize if you dive into the settings in IntelliJ. And also in the settings here, you'll find different options on when hot reload should be triggered. So you can have it happen on save actions, on a custom shortcut, or on external changes. So for example, if you have an agent editing your code, then the IDE can pick up those changes happening and trigger hot reloads automatically. So you can lean back and watch the UI update as things are happening in there. We also have some other IDE tooling, which has been added, such as this little floating toolbar up here, which shows you the hot reload state right in the IDE. So if you prefer to have your IDE and the running app on different screens, for example, and if you prefer to see this in the same view, then you can now do that. And if you open the run window, you'll also see that all of the compilation messages and hot reload information also gets propagated there. So, for example, if you break your code, then you can easily see those error messages, navigate to them, and fix them. From where, of course, hot reload is also able to recover. Right. So that's our default experience for getting started with a new project, as well as a look at Compose hot reload, which is now stable and built in with no extra config required. Right. Next up, let's take a look at new Compose Multiplatform features that are there for all of our platforms. And there are a lot of features like this, which come from Jetpack Compose, which Google builds for Android. And then we go from there to expand it with support for additional platforms, creating Compose Multiplatform. Now, both of these frameworks have been through several release cycles over the last just 1 year here. As you can see, most of the time when a Jetpack Compose release comes out, then there's fairly quickly Compose Multiplatform release with the same stability trailing the Jetpack Compose one.
And I think if we're looking particularly close here, we can also see that the actual distance between those are also getting more narrow and narrow. So you're getting the features in Compose Multiplatform that originally come out in Jetpack Compose more quickly over time as well.
Yeah, so even the latest experimental APIs, if they land in Jetpack Compose, like in 1.11, which has a bunch of these, you can very quickly start playing with them on multi-platform as well. If we take a very brief look at an overview of features in the last year, we can see that, again, a lot of things have shipped here. So there were new modifiers for interactions and new kinds of UI customizations. There were transition improvements, including shared element transitions. We have, as I mentioned, a lot of new experimental APIs in 1.11 for layouts and styling. And these are so many things that we could not possibly cover all of them, even in this entire talk. So we're only going to look at 2 of these common improvements, which are going to be nav3 and the new unified preview annotation. Starting with nav3. So nav3 is the latest navigation library for Compose, coming from Jetpack Compose and also available in Compose Multiplatform now. It was built for Compose use, so it can do away with all the legacy of the previous official navigation library, which was still based on some older Android concepts, and can make the best use of the framework. It's also very flexible. It doesn't own its own internal state. Instead, you get to own a list of keys which represent your backstack. During navigation, you can edit that arbitrarily. You can store it anywhere in your application. And then the navigation library just takes that as an input and renders UI for you. It's also designed to be adaptive from the start. So if you're designing for screens, that might change as the user is doing interesting things with their device. Or if you're just designing for phones, tablets, web, desktop, for example, then you already have APIs like the scene APIs built in that help you arrange UI in different ways for different screen sizes. And you also have APIs like scene decorators, which make it easy to add these kinds of decorations like these navigation bars in different places in different device configurations. It's crucially multi-platform, which of course is very important from the Compose multi-platform point of view. And there is one more thing about it. It's actually already stable. So you can start using it with Compose multi-platform already. OK, let's take a brief look at what nav3 looks like in practice. And for this, we're going to use the Kotlin Conf app again. And we're going to hop into the routes. So here we have, for each of the screens that we need to be able to visit in the screen, we have a class defined. For example, for the session screen, which we want to open for a specific session, that's going to be a data class, which has that property inside it. Or if we take a look at other screens, like the terms of use, for example, which don't need parameters, those can just be created as data objects without any properties in there. We can look at the usages of this data class and find the DSL where we actually tell nav3 how to render each of these keys in the backstack to actual Compose UI. So we can create an entry like this for the session screen. We get a lambda where we can provide composable content. Here, we can already see the incoming parameter to this lambda, which is going to be the key that contains things like the session ID that we just defined earlier. And then we just call into some composable implementation that will actually render that on the screen for us. All of these things are connected by the nav display in Navigation 3, which, if we go to its definition, you can see it really just takes the backstack as a parameter. It's just a list of objects that you can manage and pass into the library. And then just looking at the parameter list, it obviously offers a lot of customization through different APIs. For example, you can, of course, fully customize all of the transitions, both globally for your entire navigation setup, or screen by screen, each of the transitions and animations between destinations. If we hop over to the simulator, where I already have the Kotlin Conf app up as well, what you'll see is that we also have default transitions and gestures included for iOS. So if we navigate into a session or a speaker page, then we can automatically slide back from the side, just like you would naturally expect to be able to do in an iOS app. And the other platform that I want to have a quick look at is the web, which I also have running here, which is deployed to GitHub Pages. And you can also use Kotlin Conf app on the web if you'd like. And here, again, I'm going to navigate through a couple pages. So we can hop into the speakers find one of their talks. Maybe we can go through the map. Maybe we'll change the theme. And as we do all of this navigation, we actually built up a navigation stack here, which integrates with browser navigation. So I can navigate back through all of the screens that we just visited, and I can also navigate forward, which is something that you might expect to be able to do on the web. That last bit comes as a separate library, because there are multiple different approaches that you can use for browser navigation, depending on what your preference is and whether you want more of a desktop or more of a mobile experience. So you can choose all of those approaches using this navigation 3 browser library. And you can also find the code for integrating it right in the Kotlin confab code base. For more about nav3, you can take a look at nav3 recipes. We have a multi-platform fork of those. So for every common kind of pattern that you want to implement for navigation, you can find a repo with lots of great samples. And of course, we also have extensive documentation on how to use nav3 with multi-platform. Finally, there's also a dedicated talk about Navigation 3, which will cover all the APIs and the thoughts that went into them and how you should use them, which is being given by Googlers who worked on the library. So that's the best place for a real deep dive into Nav3. Right. The other feature that is common to all platforms is going to be previews. So here, if you used previews before, you might have seen that we had several different preview annotations for different platforms and use cases that were available. The good news is that we have massively simplified this. So now the original Android X preview annotation is actually available in common code. So you can use it with your shared Compose Multiplatform UI, and you can get all the tooling support for it that you expect. So you can use things like multi-previews, like preview light dark, which are built in. You can parameterize previews. You can use interactive previews. And all of these features, including the latest things like preview wrappers, are already available even with Compose Multiplatform. And of course, if you want to move from previous setups to this latest annotation, you can find, again, extensive docs, which will help you with migrating through and making sure that all of your dependencies and build config is just right to make sure that your previews work.
Very good. So far, we've only looked at changes that were related to all your common code. But of course, we're also continuing to invest into the individual platforms. Compose Multiplatform on iOS has been stable for quite a while now. But we're still bringing more and more improvements to it. So now it's proper to say that Compose Multiplatform for iOS is faster, it's glassier, it's text inputier. Does that work?
I don't think those are words.
All the more reason to move on quickly to our first point with faster. Because since last year, we've worked on a new, improved, and parallel rendering pipeline for iOS. And with Compose Multiplatform 1.11 being out, this is already the default. I always love kind of looking a little bit under the hood here, so let's spend a couple of minutes on that. This is how we used to render things. Márton, do you see any issues with this picture, perhaps?
There are a lot of things on the main thread.
That's right. And, well, if the main thread is blocked, it can't really do any other things. So the first step in our migration here was to move as much as possible away from the main thread onto a dedicated render thread. And we actually also went one step further. We figured out that by dropping to some lower-level APIs and doing some things more manually, rather than just getting things from the system, we could also actively shorten that wait time for new drawables. So frames actually arrive more quickly. That's just faster rendering performance straight up, not just freeing up that main thread. And we're looking at this in our benchmarks, and we're seeing that if you have complex layouts, you're getting up to 20% improvements. And if you're heavily relying on canvas drawing, so canvas-based rendering for components, then we're also seeing somewhere a little bit above 10%, some might say 11%, performance improvements here. Now, these were all changes that were kind of under the hood, right? You don't really have to do anything, you just get them for free by upgrading. But we also have new things that we can actually play with, and I also want to shout out those. One part of those are overlaid interop views, the other one are truly native text fields. And we'll spend a little bit of time on both of them, starting with our overlaid interop views. Now, the motivation for this is pretty clear. It's liquid glass. And I mean, I can kind of understand why iOS developers are so hyped about getting liquid glass into their applications all the time. I grew up with the original liquid glass implementation. And it did look really sleek. I mean, look at the trash can. It's gorgeous. It's
beautiful.
Gorgeous. Yeah, it really is. So I understand that people want to have that same functionality in their Compose multi-platform applications. And so let's take a look at what the state of that actually is. I'm going to move on over here, and I'm going to switch us over to an application that uses Compose multi-platform. I'm just going to start that from Xcode, as controversial as that may seem. Give that a second here. I'll pull up the simulator. Very good. So here's our application. First of all, the good part was that without us even really doing anything, there were a couple of parts of liquid glass that you could use in your application right out of the box. Why? Because, well, all the components, or like your entire Compose multi-platform application is simply rendered out as a UI view controller. So if there are any components that are like higher up in the hierarchy, for example, like a native tab bar, if that's liquid glass, that kind of just works out of the box. And we didn't even have to change anything about our APIs. You just get these like nice little refractions and so on straight out of the box. But there is, of course, a second style of interoperability as well, and that's the ability to embed native views into your composition, right? Like, for example, maps that should still be interactive in some way. They should behave properly, for example, in the context of scroll, right? Like they should scroll with your composition. And you might also want to add new elements on top of this that are composables that you can click to do some things like navigation, for example, or changing some things around. And the way that we implemented this is something that Xcode can actually help us visualize quite nicely. I'm just going to press this little button here, and we'll wait for a quick preview render. There it is. And now we do a little bit of tilting.
Ooh.
And we see how this is actually constructed. What's happening is that we have our Compose UI view controller in the front, which renders everything, and then it has kind of like a cutout. That cutout doesn't have to be like a rectangle like we see here. It has rounded corners. It can have arbitrary shapes. And then behind that is the native view, in this case, an Apple map. This has a couple of really cool benefits. One of the obvious ones being that Compose multi-platform stays in charge of like all the touch events, right? If I have a button that sits on top of that map, I can still click it. Compose still gets that event and can do something with it. But you can probably also spot something that might become a bit of a problem. So if I continue running this application, and I'll move over here to our other like little tab, here I tried doing the same thing and adding a liquid glass button. But of course, it doesn't really look right. Even if I'm like switching around the different kinds of styles, I'm not really seeing anything from the background. And I mean, it kind of makes sense, right? We have the understanding now, if you are behind the rest of the composition, there is nothing to like refract to, there's nothing to be transparent about. And this is exactly why we added our new interop API. In here, I have my platform-specific action button. This is just our UI kit view, so it uses the same sort of interop APIs that we've already had for a while. And here, I can just auto-complete myself our new flag placed as overlay. It does exactly what it says on the tin. Rather than being a cutout, now we're moving that exact same thing up to the front. Rerunning this application with this new flag enabled, I sure would like to replace it. We'll change things around. There we go. And like that, if I'm now, whoops, sorry? Oh, I'd set it to false. Oh my God.
Autocompletion.
So the Boolean flags work. It's very, yeah, I can blame AI. I can blame Márton for not pointing it out to me. Let's rerun that. And I'll look at you until the build is done.
I saw it during completion. I thought you were changing it after.
Well, blame shifted. OK. Hey, look at that. Look at that button. And if we're doing this transparently and we can also like move this button around, we get all these nice refraction effects. So now we can have true liquid glass components as part of our composition that look right. And of course, obviously it's a button, so you obviously still want to be able to attach things like click events. You can still do that and wire those back into the actual Compose application. But now these click handlers are actually being done by the operating or by like the iOS side of things, right? Because that you're just hitting a native component directly. But on the bright side, it also means that I can like take this button and I can like really squeeze it like this for some reason. I don't know why they added this, but you know, all those wacky little animations you can also add to your application. Right. So API itself, pretty simple.
You just set it to true?
Yeah, you just set it to true. Important.
OK, so I can basically just do this for all my UI kit views. I can put like liquid glass everywhere, yeah?
You can, but please don't. This isn't my advice. This is Apple's advice. If you're looking at the Apple developer documentation, there's one part here, which I'm going to pull out into a liquid glass component, which is avoid overusing liquid glass effects. The reason for this is that it draws attention to whatever is behind the content rather than really what's in this thing. And if I may add a personal note, it's also not that legible if you ask me. If you want to know how we did this in PowerPoint, come find us later. Very good. So use it sparingly, but you can do it now. If you want to get a little bit more advice on how you can implement this in your own applications, we have a support article for this for native iOS navigation that uses those liquid glass components that wires all of these things back together again. And then there's a second part, which is the iOS text input story for us. Now, we already used certain implementations from the system, but now we are pushing towards truly native iOS text input.
So nitty.
Yes, indeed. So let's get into the nitty-gritty of what we will be seeing. There we go. That it does not deserve an applause, but thank you nonetheless. Let's see what we have here. And this is all about the behavior of your cursor and your virtual keyboard. So here I have this already enabled, just for brevity. And you'll notice that if I tap once here, it moves my cursor. If I tap twice, it does indeed select a word. Triple tap selects everything. I can, of course, move one of these handles. And once again, I get this extremely playful component. None of these things are like emulated or any way. They're not a recreation. They are just the real iOS like magnifier, for example. It also now provides us with a couple of other features. You'll see that if you've done this before, you may have seen cut, copy, and paste, but now we have the full integration with everything that iOS has to offer here. So for example, since we are in Germany, I'm going to continue here, and maybe, OK, I guess because we're in Germany, I'm going to translate it to French. I'm not going to attempt to pronounce that. But very good. So, for example, translate works. Or if you would like to autofill this information and we'll put John Appleseed's personal information onto the big screen here, thankfully he's not real, we can do these kind of autofill operations now as well. In addition to this, we also now provide you the full range of IME options that are provided by iOS itself. The decimal pad is something that you've already seen because that's a cross-platform thing as well. But we also have really cool features like the Twitter keyboard, which allows you to access the @ and the hashtags. I'm not calling it Twitter just out of spite. Indeed, if I actually take a look here, and we are taking a look inside of that implementation, if we're taking a look at the imports, we will find that the UI kit itself calls it UI keyboard type Twitter. So this comes from Apple. Can't do anything but call it Twitter. I'm sorry. It is what it is. In addition to this, we also have we also allow you to attach new custom views to your IME. So for example, if you're building some sort of scientific calculator, you can bring in these kind of views. I hope it's kind of visible up here. They are dedicated buttons with their own little circles. The contrast might not be so great, but if you're building something like this, you can of course just allow people to really easily change around things or give them shortcuts, for example. Right. So we've seen that on iOS, we're investing in performance, and we're investing in interoperability. We've seen overlays, and we've seen native input methods. There is one thing here that, quite frankly, doesn't really look right yet, which is auto-sizing. And that's one more story regarding the interop views. Because iOS native views have the concept of an intrinsic size. I think it kind of makes sense, right? If you're a text label, you probably know how you want to be laid out. With our most recent additions, we are now simply wiring these things together properly so that the surrounding composition can properly respect any constraints that are coming in from those interop views, and things just look right. It's a small change, but it's one that you probably don't want to miss. Right, that's iOS.
And that takes us back to the web, which, as I already mentioned, graduated to beta recently. And we had two big new features introduced in that beta release. One of them was accessibility, and the other one was interop with HTML, just like you can interop with native views on all other Compose platforms. And for this, we're also going to go to a demo straight away. So we're going to hop over into Chrome. And we're going to look at this page here, which I have running locally, which is a couple different small Compose samples, which each have some HTML embedded into them. So for example, this restaurant page here, you can browse the menu, you can look at the opening hours. But if you take a look at this sidebar here, this resizable and interactive map is actually a leaflet map, which is a piece of HTML content which sits inside our composition. Or if we hop over to the video player page, we can browse videos, contents, all your favorites from the Kotlin YouTube channel, hopefully.
I love that video. It's a good video.
Right?
Yeah.
And you can also play this because it is a YouTube player embedded as an iframe right into the composition. And you can see that it moves and scrolls and behaves just like other interop views. And you can also hop to the third tab here, which is kind of a smart home dashboard kind of setup. So you can take a look at readings from sensors. You can browse things by different rooms. You can see your energy usage, your device states, and so on. And here, the interop view is the one sitting right in the middle. This chart here is actually built with Chart.js. And you can see that it's interactive. It looks just like all the other views. It fits in nicely with the rest of the application. And again, resizing it and things like that also work really nicely with the rest of the app. We can take a brief look at how this works if we hop over into this project, where we have the code for the video player for the web open, for example. So we are using an expect actual composable to have different UI implementations for different platforms. And on the web, we are taking the incoming ID. We are constructing the URL that we want to load into the frame. And then we have the interop API call, which is HTML element view in this case, which works, again, with the same patterns as the other interop APIs. So we have a factory that's supposed to create the element, in this case, creating an iframe, setting a bunch of attributes and even CSS on it. And then we can have things like an update method, where we can continuously synchronize state from the Compose world into the interop views if we ever need to update them. If we go back to this app, we can also take a brief look at accessibility with Compose. For this, I'm going to turn on the voiceover on my machine. But we're going to do that without having voiceover speak over me constantly.
I think that's probably the best way to do it.
So we're going to rely on this little readout here, which actually tells us what voiceover would be reading.
Video player button. Chart button.
Exactly like that. So as you can see, voiceover and Seb can both read accessibility information from the composition here. So we can use standard tools like VoiceOver to hop through all of these things. And this, again, relies on the same accessibility information that you would use in other Compose platforms. So you work with semantics, modifiers, things like that. And just like we support it on iOS and elsewhere, you can now also make
VoiceOver
use
off. voiceover off.
You can now also make use of this on the web.
Nice.
We also have a bunch of exciting performance improvements on the web recently. For example, scrolling performance has been massively improved. And if you use the coil library for image loading, our colleague Kostya has contributed updates there so that it now does its image loading multi-threaded on the web. So it uses web workers and gets that work off of the main thread as well. This is a talk that happened this morning.
So time machine it is.
But you can probably just check it on YouTube, which might be easier once the recording is up.
I would prefer the time machine.
I mean. All right.
OK. So we've seen plenty of things happening in the Compose multi-platform world. We saw that we have a technology here that powers the lives of hundreds of millions of users and that can scale to really, really large applications in a way where you get to choose how much or how little you share. You don't have to rewrite your application from scratch. Instead, you can really start doing it part by part. We've seen that we're really, really keeping step with Jetpack Compose. And in fact, we are kind of like catching up, making those differences in release times even shorter, which means you get things even more quickly to play with. And of course, we've seen that besides changing things and improving things, on the cross-platform, on the common layer, that we continue improving the individual platforms themselves as well, because we want to make sure that you get the full power of whatever platform you target. So with that, we hope that you will build your next application that uses shared UI using Compose Multiplatform. Our entry point hasn't changed. It's still jb.gg/compose. And we, of course, also cordially invite you to join the Compose multi-platform related channels on the Kotlin Lang Slack. So with that, all I can say is thank you so much. And please do not forget to vote using the Kotlin Conf app, which we've already seen hot reload a little bit, which is a good indicator that it is indeed a multi-platform app. iOS, Android, and even the web, by the way. Try that out as well. Thank you so much. Have a nice Kotlin.